We have taken a chapter which name is motion and measurement of distance. We will understand meaning of motion, types of motion, meaning of measurement, types of measurement, what are those tools, what are standard tools, what are non-standard tools. All things that will be important for understanding from perspective of this chapter. So here first we are starting from definition of measurement. When we when we listen measurement word, we are we are clear that yes, measurement of something. We are measuring something. Somebody is measuring something. We can measure this. We can measure length of this marker. Yes. So here, what is the meaning of measurement according to you? I wanted to ask you, what will be meaning of measurement according to you from your side? Most of you would say this is just a measurement. Anything we can measure is measurement. Most of you would say, and most of some from some of you would say we use measurement. We use we do measurement to know a noun thing, a noun thing. Okay, we do measurement to noun a noun thing. Yes, to noun a noun thing. Okay, so let's see exact meaning of measurement. Exact meaning of measurement. Here we want to know a noun thing. That's why we use measurement. We want to know what is the measure of this, what is the length of this marker, and here we are trying to know. What are we trying to know? Measure of length of this marker. So when we want to know what is the length of this object, we are doing what? We are measuring. So this process is what? Measurement. This process is measurement. So you are crystal clear. Whatever we want to know, let's say what is the weight of this, what is the weight of this. So here we are measuring this. We are measuring this in kilometer, in meter, you can say in meter. So what will be measurement of this in mass, in form of mass? What will be mass of this marker in kilometer? No, in meter. Even you can tell mass of this marker in kilometer if you have understanding of kilometer. Okay, so that's how you will find mass of something. That's how you will measure length of something. That's how you will be able to find meter. That's all. Okay, that's all. Meaning of measurement is to measure something. We do measurement because of we want to know. Somebody wants to know what is the measure of that object, what is the mass of that material. So here somebody wants to know from a noun thing. Okay, from a noun thing. Now number and unit. Number and unit. Carefully understand. Okay, number and unit. We should have a number. We should have a unit. We should have a combination. Exactly. Actually, we should have a combination of number and unit. Number, you know what is a number. Okay. Unit. What is unit? What is unit? It is just what? centimeter, meter, kilometer, all this, second, minute, hour, all these are units. All these are units. Hmm. I told you, I said you, we should have a combination of unit and number. For example, length of this marker is 2 centimeter, not 2, 5 centimeter. Okay, 5 centimeter. I think 2 cent, 2 to 4, 5. Yes, 5 centimeter. Approximately 5 centimeter. So here I have written length of this marker, which is 5 centimeter, which is 5 centimeter. Now what is the meaning of this 5 centimeter? It is a telling you, it is a telling you, and it is in mathematics. We can say measurement of this marker is a 5 centimeter. Okay, 5 centimeter is in mathematics. Here it is a telling that length of this is 5 centimeter. Now you can see we are showing measurement of this by saying 5 centimeter, 5 centimeter, like that. So here, whenever you will measure anything in mass, in meter, okay, whenever you will measure, so you will get a number with unit, you will get a number with unit. So here you will get two things, first number and second unit, first number and second unit. Now from this you can observe those two things that I told you right now. So 5 is it a number? Of course, yes, it is a very basic. It is a number. Now, centimeter, as I told you, centimeter, meter, kilometer, millimeter, liter, all these are units. All these are units. Yes, we would say centimeter is unit. Now, what will happen when you would say, rather than saying this, you would say uh, measure of this is what, 5, only 5, without unit. You are saying 5, length of this marker is 5. So it will not make any kind of a sense. Of course, it will not make. So now, what is the meaning of this 5? From this discussion, you will get a clarity. You will get clarity. 5, it is also telling, it can tell that we have a 5 number of this marker. 5, it can tell you that I have 5 markers. I told you that length of this is 5. And after few days you will think, you will remember that Deepak has 5 markers, and Deepak was telling me at that day. So here you will not, you will get confused when you will add unit with 5. Then you will think, okay, Deepak was telling that mm, length of that marker is was 5 centimeter, like that. You understand, like that. Most people understand. Okay, most people understand. So alone number will not make any sense. We will have to use centimeter, we will have to use unit with number, and unit only we use only unit, then of course again it will not make any sense. So we will use both number with unit. So here this 5 centimeter is a telling it is a telling a measurement, it is a telling a length of something. So length, it is a telling length of this marker, length of this marker. Clear? So we represent measurement. We represent measurement is represented by this, by a combination of number and unit. So remember how to represent measurement. How to represent measurement? So measurement is represented by a combination of two things, and two things should be a number with a unit, a number and unit. Okay, a number and unit. So we understood how to represent measurement of something and what is the meaning of a measurement. What else apart from this? Have you ever seen? Have you ever seen a tool, ruler tool? It is found in geometry. It is found in geometry box. Ruler. It will be how? So here, ruler looks like this. This is not exact, but almost a ruler looks like this. Yeah, it is a tool to measure a state, a state object. We can use this tool to measure a state object. We can measure this phone device, this measurement by using this scale. We can measure this marker area length by using this ruler tool, because of this object is in state. That's why we cannot apply this ruler tool with with unshaped, with irregular shaped object. Okay, so here, from here, we find what, for example this. Okay, for example this, I will put, I want to know what is the measurement of this in length. Then I will put this on this here, and here from 1. So here I am getting how much? Let's say here till here. So here from this is 1 centimeter, this is the second, and this is third. So till here, let's say till here is how much? So you would not say that you length of this is getting 4 centimeter. No, we started from 1. So this is 1 centimeter to 3. So now we would say length of this marker is of 3 centimeter. 3 centimeter. Okay. So we started from 1 and it ended here 4 at 4. So 3 centimeter. From here to till here is how much? 3 centimeter. Clear? 3 centimeter. So 0, between 0 and 1 is 1 centimeter. Okay, between 1 and 2 only 1 centimeter. So that's how we measure a straight object with the help of a ruler tool. Do you know what is a hand span? What are those? What are this? What are this? What are these? This is a standard tool. This is a standard tool and it is used at a global level. This ruler tool is used at a global level. But here, hand span, cubit, foot, palm, yard are also tools to measure something. And all this all this used to use in ancient time, in a decent time. You can say I go 50 years 50 years ago, 60 years ago, 70 years ago. So all these were tools to measure something. Okay, all these were tools to measure some things, and all this used to use in ancient time by those kind of peoples. But now we don't see uses of these tools. We don't see surrounding us, even in market. But all these tools you will not get in market. All these are just what? Hand span. It is saying what? Hand span, which means we open this hand, and we will put like that. So here we are saying that from here to till here is 5 centimeter. From here to here is 5 centimeter. So for example, I measure this, then I am getting what? I am not able. What is a measurement of this? I am not able clearly. Okay. So this is how we use. This is known as hand span. Okay, hand span. For example, this is book. Okay. For example, this is book. In ancient time, this hand span used to use to now measurement of a book of anything like that, and then four figures like that. So this was a hand span, and second cubit, which means from here to till here, For example, this from here till here is 1 cubit. How much? 1 cubit. And second, from here is 2 cubit. 2 cubit. So till here is a 2 cubit. Now you can see one. Okay, one till here. So here you would say one hand span, and here we are getting 4, and you can say 6. So 6 fingers. Okay, 6 fingers. So that is how people used to do. Use. Okay, that is how. So from here to till here is 1 cubit. From here to till here is 2 cubit, and from here to till here is what? One hand span. Now people used to say that what is the length of this board? What is the length of this board? So people used to say that 2 cubit, how 2 cubit, one hand span, 6 figure. So people used to say 2 cubit, one hand span, 6 fingers, like that. But it was not it was not convinced. It was not very easy. Sometimes people got confused. Okay, because cubit of any people will have a different size of cubit of some people will be different. according to age, according to age. So that's why people got confused. Okay, even hand span, when it comes to hand span, so hand span of different people will be different. Okay, here foot, foot, foot of leg, palm, yard, it is saying what, from here to till here, yard, this is yard, this is yard, arm, from here, from figure to till the arm, 1 yard, this is known as 1 yard. Otherwise you can see 1 yard, here is 1 yard, and one cuboid, one cuboid, and 1 yard. So it is equal to what? It is equal to 1 yard, 1 yard, one cubit, isn't it? 2 cubit, one hand span, 6 figures is equal to 1 yard, 1 cubit. So it was very difficult. It was very long way, and people got confused. That's why gradually a lot of tools came into picture to measure a lot of things. And in today's times, we use this kind of tools, which are known as standard tool. And these standard tools are accepted at a global level. Even we go abroad countries, then people will use this ruler. People will use this ruler. So this kind of tools, not this kind of tools. Now these are not valid. These are not valid in today time. These are valid. These are valid. This kind of tools are used in anywhere, on anywhere. Okay. Now we are going to understand uh, standard tools, non-standard tools. Now we are going to understand this. We have a lot of standard tools that are that are globally, that are state at accepted at a globally level. Okay, that are globally accepted, but non-standard tools which are handstand, palm, yard, cubit, all these are non-standard tools to measure anything. So all these tools are not globally accepted in modern time. Okay, so all these are those who are not globally accepted. So non-standard tools are not globally accepted. Non-standard tools are not are what are inconvenienced. They don't make sense. They do not make sense sometimes. Okay, but standard tools are globally accepted and they are convenienced. They make clear and clean and clear sense. Okay, you can use anywhere, anytime, and you will get result same. You will get a result same. It will not happen. You will measure here this. You are getting 5 centimeter, and you will measure this marker in USA country. Then you will get what? You will get a measure of this 6. No, it like that will not happen. Never like that will happen. Okay, you will get what same 5 centimeter measure of this marker in US, and same here. There will not be any change. There will not be any changes. Okay. Now, SI unit of length. SI unit of length. SI unit. A small unit. No, system unit. Okay, system unit. So SI unit of length. Of length. What is what? Length. What if I ask you SI unit of time? SI unit of time. Then what would you say? You would say minute? No. Only I think second. Second. I think so. Second. Second would be SI unit of time. Now here SI unit of length is what? Meter. It is what it is at a level of international. So I can't say anything. It will be universal truth, and it is a fact. Okay, it is a fact. Now let's understand. Let's discuss about unit convergence. We will convert units into another unit. Let's say you are taking 1 kilometer. You are taking 1 kilometer. So how to convert this kilometer in meter? In meter. Okay, how to convert? Just you okay. You will have to remember that 1 kilometer is equal to 1,000 meter. 1,000 meter. You will have to keep in your mind. If you will have to keep in your mind. So here meter 1 kilometer 1,000 meter. Okay, 1,000 1,000 meter. 1 meter is equal to I think 100 centimeter. 1 centimeter is equal to 100 millimeter. Is it correct? Is it correct? And 1 centimeter is equal to 10 millimeter. 10 millimeter. Okay. All these are facts. All these are facts. All these are facts. This is a small, this is less than kilometer. Okay, this is very basic. We will understand with some questions about it. Measuring a curved line. How will it be possible? How to measure a curved line? If a curved line, it is a flexible, it is not rigid, then we will what? We will use our hand. We will pick a end of a curved line like that. Then we will pick up a another end of that curved line like that, and we will stretch the curved line so that it can become a straight line, and then we will put along with a ruler. Then we will get measurement of this curved line. Otherwise, you can use, we have what flexible standard tools. We have flexible and standard tools. Instead of using ruler, you can use flexible tools. For example, uses uses what? Tailor uses flexible. Tape. I don't know what is the name of that tool. So tool that tailor uses to measure shoulder, to measure hand, to measure height of a body. So that tool we can use to measure curved line, and that is why flexible tool used for curved line, for flexible object, for flexible object. So we can measure curved line by using a flexible tool, flexible standard tool. Okay, flexible standard tool. Now next, we have done we have discussed concepts regarding measure. Now what about motion? So here, rest and motion. Rest and motion. What would you like to say about rest and motion? In your language, what would you like to explain about this word? Some of you would say rest. Somebody is doing rest. Somebody is taking rest. Somebody is relaxing, and object can take relax. Okay. So here, uh, in physics language, meaning of rest, it is saying that anything is not changing. An object is not changing its self position. Okay, so position of an object is not changing with respect to time. You can say with respect to time. Okay, here you can see this is what. Okay, now can you tell me, is there any change of this position? No, but time is a passing. You can say time still is a passing, but the position of this board is not changing. Is not changing. We can say until we will not apply external force. Okay, until we will not apply external force. But here we are not applying external force. Here it is not moving at all. And but what time is going on. Time is passing. So any object is not changing its self position, then we can say that is in rest. That object is in rest. But there is a twist. Twist is that here we will observe what time and position of an object. Here I am here. I will go like that. Oh, 1, 2, 3, 4, like that. So here I am here. Okay, I am here. A. I am here. Okay, and I went here. So let's say B. I went here at this place. Uh, within 10 minutes, you can say 10 minutes. Within 10 minutes. So here I went to tell here in within 10 minutes. Within 10 minutes, and my position changed. My position changed from here to till here. Let's say this is object, this is object, this marker. Now you have to tell. So here you have to tell here. Now this was here, and this came here. This came here. For example, this is here, and here you can see this came here. So now position of this object changed. Okay, is changed. Now and with respect, what was the time? Just time was a 2-3 seconds, you can say 2-3 seconds. In within 2-3 seconds, it came from here to till here, and here we can see time which was applied. Time was 2 seconds. Let's say 2 seconds, and position of this object uh, is what changed. Position of this object was here, and now it is here. So position of this object is changing. So we can define any object when that object will be in motion. Then we would say yes, any object is motion because of position of that object changed, and with respect to time. Yes, any motion will take time. Anyhow, any motion of any object will take time. It is a universal truth, you can say. It will happen. Yes, any motion object will take time. Yes, it is a truth. So from here we understood understanding of rest, definition of a motion word. Now let's understand types of motion. First is We have five types of motion. We will break down each types of motion. Okay, first let's start from definition of rectilinear motion. It is very simple to understand it. You will get confused where in understanding of rotational, in understanding of periodic motion, and in understanding of a circular, and this in this you will get confused. But don't worry, with understanding you can get a clarity. Okay, clarity. As I told you, this understanding of rectilinear motion is a very simple. It explains that any object is uh, is moving, but that object should be should be moving in state. Main point is what in state. Now here, why why are we not saying state motion? State motion. Why are we saying rectilinear? Rectilinear. Because of because of. I think so. According to me. According to me, there can be more than one object. There can be more than one object which will be moving in one state. If two or three objects together are moving in a state, now this will be what motion of these three objects will be considered as rectilinear motion. Okay, rectilinear motion. So two or three or four objects are moving in a straight direction will be rectilinear motion. Okay, will be rectilinear motion. And objects can be any type of object. Can be any object. Okay. Here we are understanding just little meaning of each types of motion. With questions, we will explore it more. Okay, we will understand more about this. Now, circular. When I listen, the circular word, then in my mind a word comes which is a circle. So circular motion, it is the same. A object will be moving in a shape of as a in a shape of a circle like that. Object will be moving like that. So here let's say this marker is object. So here's in circular shape this object will be moving. And now we would say this object is moving is what? A circular motion. Okay, like that. So circular or rotational. So here mm, you can take this. Okay, this is fixed, and here you can take this. Here we have fixed this center. We have fixed this center, and it will move. It will be moved like that. So here there is a fixed. If axis of an object, otherwise you can say point of a object is a fixed, is a fixed, is a fixed, and that object is moving. That object is moving. So we would say that motion is a rotational motion. Yes, I know we can get confused, but wait for a few minutes. Oscillatory motion. It says anything. Uh, let's say this. We apply force. Okay, we apply force, and it will go like that, and then it will come back automatically without applying force, external force, like that, like that, like that, and it will stop like that. So it is doing what? It goes here, and then it will come back automatically. So this is what true and this is pro. It will go forward and it will come backward. So this kind of a motion is a oscillatory motion, and we see example we can take, which is in a real life, which exists. Swing. Each swing is an example of a oscillatory motion. So it will go, then it will come back, then it will go forward, then it will come backward, it will come backward. Now periodic from periodic word, it is explaining that it will take interval time. Okay, for example, in 5 minutes it will come again back. Okay, it will come back again 5 minutes. So their internal interval will be fixed. For you can take an example of clock. So after 1 hour the hour hand will again move 1 hour hand, then again 1 hour hand. So it is what our hand of our hand is fixed after 1 hour. Now our hand will move after 1 hour again. So this 1 hour is fixed, and we can consider this 1 hour as a interval time, as a interval time. So anything which any object which repeats after taking a complete time, and again that object is repeating. So one taking complete motion is what fixed. You can say we will consider that as uh, interval time. Okay, got it? Now we have some question. First question is, read question carefully. Now question is saying, it is saying which of the following is not a correct representation of measurement. So one thing of this is not a correct way to represent a measurement. So you have to tell which one is not, which one is correct, which one is not, which one is incorrect. Okay, which one is incorrect. So time duration, we so here you, if word is a measurement and measurement is represented by a combination. Measurement is represented by combination of number and unit, and both will be together. Now here, time duration is how much? 50 seconds. 50 seconds. 50 is 50 is number, s is unit, which is a second. It is a SI unit of time. Now here it is a measuring, and representation of time duration of it is correct. Now see, volume is how much? 2 liter. 2 is number, L is liter, and liter is used to measure volume, to measure liquid material. Yeah, liquid material. So liter is used to measure liquid material. Meter is used to measure flexible material like clothes. Kilometer is used to measure a distance. Similarly, liter is being used to measure liquid material. Now 2 is a number, L is a unit. So this is the correct way, and this is a representation of this is correct. Now D, height we measure height of anything. We can find the height of anything. Yeah. So here height is how much? 1.5 centimeter. 1.5. Yes, it is also correct. 1.5 is a number, centimeter is a unit, centimeter is unit, and we can say representation of measuring of height is correct. Now last one, direction. Direction is what? Direction is given, which is north. Direction is given, which is north. Now there is no number. With north is not number, and we now north is a direction. North will not be considered as a unit. North will not be considered as a unit. It is already incorrect. But here number is also not given. If there is a given a number, then we see. But here it is completely wrong. Okay, it in itself is correct, but it will not come in the category of a measurement. Direction is equal to north will not come in the category of a measurement. Okay, so we will not involve this in measurement. So this B is not a correct representation of measurement. So B is the answer. Now next question. We have next question, which is this. It is saying which among of the following you have to tell which one is not a standard unit for measuring distance in a recent time. Which one is not a standard unit for measuring in a recent time? Millimeter is used. It is used. Millimeter is it is used to measure anything in a recent time. So yes, it is a standard unit. Now kilometer is also a standard unit. It is used in a recent time. Yes, meter is also a standard unit. It is also used. But yard is not a standard unit. It is a non-standard unit. It used to use by peoples 60 years ago, 60 or 70 years ago. But in modern time, yard is not used as a standard tools as a standard unit. Okay. So of course B is the not a standard unit for measuring uh, distance in a recent time. So of course yard is not a standard unit. We have done this question. Next question is which is very interesting. You will enjoy. Just let me write. So this is next question. It is also easy. The length of the outline. We will have to understand question very carefully. The length of the outline. What is what outline? For example, outline of this object is what? This is surface. For example, outline of this book is what? This outline. This is outline. Okay. not this. This is surface. This will be considered as outline. This is outline. This is outline. Okay. Outline of this board is, this is outline. I am not talking about surface. I am not talking about surface. So the length of the outline of which one of the following can be measured using only a meter scale. A scale. What is a scale? We have two words again. One is outline, second is a scale. We will have to use a scale. Okay, we will have to use a scale to measure. To measure what? Anything. We will use a scale. Okay. Now, question is the same. You have given four things. And you will have to choose only one object, and that object should be, uh, if that object can be measured by using what, meter scale, then you select that object. Okay, you select that object. Any object you can pick up, but that object can be measured by using meter scale. Then okay, that object will be used. So here, first object is what? First object is irregular shaped photo frame. Object is what? Photo frame. Here our focus will be on outline of photo frame. Let's say I don't have a photo frame of anybody. Let's say this is a frame of a book. 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 Now this is outline. This is outline. But here it is clearly explaining outline of this frame book is what? Irregular shape. Irregular shape, not regular. Irregular, which means a rough shape, like that. Okay, like that. So it is a irregular shape. Now next is a pen plate. Pen plate. You see like that. Okay, like that. Pen plate. So it is also irregular shape. Shape of length of outline of this pen is irregular shape. Now coin looks like a circle. Chessboard looks like a square or a rectangle. Now which one will be what? Will be measured by using meter scale. So we cannot use a scale to measure coin. We cannot use a scale to measure paint plate. We cannot use a scale to now measurement of irregular shaped photo frame. Yes, we can use a scale to measure chessboard. We can use a scale for chessboard. So they will be correct answer. Now next question, which I think so last. Next question will be last. But next question is interesting from my side. Next question is, Now, this is the last. Read carefully. What is the question saying? Person A is a sitting. Person A is a sitting at the back seat of a driver. At the back seat of a car. So person is a sitting. Okay. Person is a sitting at the back seat of a car. Okay. Okay. He is a sitting. Person B is a driving. Person. Okay. Person A is sitting in a car and person B is driving the car and person C is outside of the car okay. Now here person B is driving the car which is moving towards right and person C is standing on the road. You can say person C is outside of the car. Person B appears to be in motion as the same. So person B is in the car. Person B is in the car who is driving the car. Now person B appears to be in motion as seen by. So here it is saying last sentence is saying person B will appear like he is in motion. He is in motion. Here person B. Who is a person B? Person B is a driver. You can say person B is a driving the car. Okay, not person A. Person A is also in motion. But who are observer? Who are observer? Okay, who is observer? So here, if a person A is observer, person is sitting in the car. So person is observer. According to person B will be in rest, not in motion, because both are in state in rest. Both are in rest. Yes, and according to B and A person, person C will appear like he is in motion, but actually reality is what person C is standing on the road which is not in motion, but it will appear by by person A by person B. It will appear here person A. So no, it is incorrect. It is incorrect because person according to observer of a person A, person B is in rest, not is in motion. Okay. And third sentence is saying person B will appear as a motion by which kind of a person? By which kind of a person? That is what we have to take. So here both person A and person C. No. Yes, person C will be observer for this story. Person B will be person C will be observer. Will be observer. According to person C, person A and person A and person B are in motion. Are in motion. It appears, but actually we can say that both are not doing any kind of motion. Car is moving, but both are sitting in the car. But it appears that both are in motion. So according to third person, both person A and person B are in motion according to third person. But according to a person, according to person A, person B is in rest, not is in motion. Okay, so this is also incorrect. This is also incorrect. Neither person A and neither person A nor person C. But here, as we know, person C is the observer. According to person, from observer of person C, person B and person B will appear like both are in motion. So yes, B is the correct answer. So we have answered logically with reasons. So finally, that's all. We understood concepts of motion and concepts of measurement with some questions. With reasons you can